A new study out from UC San Diego, among others, that was released today says COVID-19 was spreading much earlier in China than first thought. And joining us to talk about the findings is this study's senior author, Joel Wertheim from the UC San Diego School of Medicine. Professor Wertheim, thanks for joining us. The initial thought, as far as what we kind of know to this point, or thought we knew, was that COVID-19 began to spread in December of 2019. Your study found otherwise. How did you come to that conclusion, and how long do you think it was spreading before it was actually detected?
Hi, thank you. So our study was interested in looking at how long it could have been circulating before December, and we were trying to put an upper bound on that to figure out how long that fuse was from the time the first person got infected in Hubei province until it was detected. And we extended it back to about mid-October as the earliest possible date someone in Hubei could have first contracted this virus.
So they have people who essentially have boots on the ground, for lack of a better term, that have been there trying to study it in person. How did you guys come to this conclusion to figure that out?
So we looked at all of the genetic data from the viruses that had been sampled in China in the first wave of the epidemic there, before it even became a pandemic. And then we also looked at really detailed models that some other researchers in China had developed about how the virus transmitted. So we looked back in time using the genetic evidence, and then we looked forward in time, sort of simulating the beginning of the epidemic using these models developed by Chinese researchers. And you put them together, and it tells you that you really can't start an epidemic earlier than mid-October and see the start of the pandemic that we actually observed in China.
Okay, so you're talking about October of 2019. Tell me exactly how that differs from what's been found to this point and why it matters to have that new data or that new assumption or theory, if you will.
Well, it does help us sort of look at these claims from around the world that the virus was detected in wastewater in mid to early 2019. That just doesn't seem reasonable. Or cases that were reported elsewhere in the world in, say, early November, they just don't seem as likely if the virus only would have infected, say, dozens of people in China by the start of December.
Okay, so you look at the timeline. To this point, we thought, okay, December 2019, we believe that this thing started in a seafood market. Your study finds, again, that probably didn't start there. How does that change our understanding of where this whole thing originated?
Yeah, so our study, along with others along the way, have sort of pointed to the Hunan seafood market as a potential super spreading event where a lot of people got exposed, because we know there are cases well documented from early December that didn't have any connection to the market. So although that is a source of wild animals and a potential source for the virus to enter the human population, it just doesn't look like that the outbreak at the market was sort of the introduction of the coronavirus into humans.
Okay, so as far as how this thing spread and why this particular one spread, help us understand. I believe part of your findings is that a lot of kind of viruses like this coronavirus that might spread don't actually, they just die out naturally. But this pandemic obviously became something we haven't seen in our lifetimes. What made this one different?
Yeah, so to address that, we basically just simulated thousands of coronavirus-like epidemics, and we saw that over 2/3 of them went extinct on their own, usually after only infecting one or two people. So that seems to be the natural course of transmission, and that's actually how it spread around the world. Multiple introductions to a country, only one or two actually take off. So what that tells us is that these viruses are, humans are being bombarded with these zoonotic viruses constantly, and it's only the rare few that take off. And sometimes the ones that take off or have the potential to cause a pandemic will just die on their own. So in terms of 2019, we got very unlucky because, 7 out of 10 times you rerun 2019, there's no coronavirus pandemic.
Odds were not in our favor in this go round, unfortunately. Lastly, help me understand your theory, your leading theory at this point. We don't officially know the origin of COVID-19. What is your leading theory at this point as to how this whole thing got started and spread the way that it did?
Well, our best idea is that ultimately it came from a bat in either South China or Southeast Asia, and then it may have gone directly into humans, or it may have sort of made a pit stop in another animal host along the way. And wherever that event happened, which our study can't say, it must have gotten to Hubei pretty quickly because we don't see clusters of transmission anywhere else in China or in the world before that time period.
Do you anticipate your findings, by the way, are going to change anything for other researchers around the world looking into the origins?
I think it gives them a new technique to look sort of beyond the genetic data and to say how long could this virus have sort of been around in a very, very low levels. And that I think is a technological innovation that we provided.
All right, a lot of information developing here. Professor Joel Wertheim, UC San Diego School of Medicine, thanks so much for your work and for sharing it with us tonight.
Thank you.
All right.